Okay, good day to another chemistry class. I hope you're all fine. Okay, so let's continue our topic on redox reaction. We'll be balancing more equations today. Okay, so now let's look at this. Write a balanced ionic equation for the redox reaction between tetraoxomanganate 7 Air and hydrazine N2H4 in an alkaline solution. Please note this. So now the first thing, I've written the half equation out for you. So now what we are going to do is first of all detect which one is an oxidation reaction and which one is a reduction reaction. So let's look at this one in terms of oxidation number. Manganese is +7 here. One manganese from +7. Excuse me, from +7 it is going to +2. So definitely it is coming down. So this is a what? A reduction. Because it is +7 and now it is +2. While this one, you can easily detect this one in terms of the hydrogen. Removal of hydrogen. Removal of hydrogen is an what? Oxidation reaction. Good. So having gotten this, let's start. Let's bring this one out first. MnO4 minus 2 MnO2. Now, because we are talking about an alkaline solution, note that this one is going to involve an hydroxyl air. The last one we did, the previous class, it was acidified in an acidic solution. That is why we are making use of H+. But here, we have to consider the what? The alkaline solution it is involved in. So we are balancing this equation in terms of water molecules and hydroxyl air. Note that. So now let's look at this. MnO4 and MnO2. So we have how many atoms of oxygen here? 0. We have how many atoms of oxygen here? 2. So here let us start with that of the water. This is where we're going to put the water. So here we have 4. If we say 1 molecule of water, that means this is 5. It will be a bit difficult for us to get 5 molecules of water. So what if we do it like this? 2 molecules of water. So here will be hydrogen is 4, hydrogen is 2. 2 plus 4 will make it 6. Since we already have 2 here, so for us to balance it, we'll just say 4 hydroxyl ion. So let's look at it. Oxygen is 2 here, 4 here, making it 6. Oxygen is 2 here, 4 here, making it 6. Hydrogen is 4 here, hydrogen is 2 times 2, 4 here. So it is balanced. Both the hydrogen and the oxygen are balanced. Now let's go to the what? The charges. The charges. Look at it here. We have -1. And we have what here? -4. So which side has the highest number of charge? This side. So we are going to write it like this now. MnO4 minus plus 2 molecules of water plus 3 electrons. So we are going to have this in our reactant, MnO2 plus 4 molecules of hydroxyl air. Are you getting me? Is this explanatory? I hope you got that. Now let's go. Let's go to the oxidation, the hydrazine ion. So we have N2H4 going to what? N2. This one is even straightforward. So, how many atoms of hydrogen do we have here? We have 4. Having 4 here, we can easily write 4 molecules of water. Are you getting me? Now that we have 4 molecules of water, we can have 4. It has to be 2. Sorry, where's the duster? Yeah, because this place, we have 4 molecules of hydrogen. And we have 8 here, so it cannot be balanced. So what we are going to do here is, we are going to write 4 here, and this one will be what? 2. Is that taken? Because, okay, 4. And we can leave it, let's see. If we leave it like this, and if we want to balance the, what is the number of molecules? You know, we can only have, this is what we are going to have. Good. It's balanced. We can leave it like that. How many molecules of hydrogen? 4, 4, 8. 4 times 2, 8. How many molecules of oxygen? 4. And this one too is 4. Good. So that is balance. Now let's balance the charge. What do we have here? We have -4. We have -4 there, but this side is 0. This side, there is no charge, it is 0. So if you want to rewrite it, we are going to write it like this: N2H4 plus 4OH minus going to N2 plus 4H2O to give us 4 electrons to make it balanced. Do I have to adjust my lens, or it's okay like that? Yeah. So can you see that? This is that of the reduction. Can you see? This is the reduction, while this is what? Oxidation. So now the next thing for us to do is to cut out the number of electrons. But it is not balanced. We have 3 here, we have 4 here. So for this electron to balance out, what do we need to do? We'll multiply the whole of this one by 4. And we multiply the whole of this one by what? 3. Good. Oh, let me see if I can make use of the other board. Let me make use of the other side so that we can balance out our, sorry. Okay, I think you can see. Can you see it well like that? Okay, so let's go ahead and balance. We'll multiply that one by 3 and we multiply that one by 4. Now let's go. Let's write it out first. 4 MnO4 minus plus 4 times 2, 8 molecules of water plus 12 electrons plus, going to 3, 4 times 1, 4, 4 MnO2 plus 4 times 4, 16 OH minus. I hope you can see it. Okay, now let's go to the next one. 3 N2H4 plus 12 OH minus going to 3 N2 plus 12 molecules of water plus 12 electrons. Good. So we have successfully balanced out our number of electrons. So who can tell me what else again do you think we can easily cut out? Now, apart from the electron, look at the molecules of water. Look at the molecules of hydroxyl ion. What else do you think we can do there? Now, this is gone. Well, we have 16 here. We have 12 here. So 16 minus 12 will give us 4. So that means we have 4 hydroxyl ion left. We have 8 here. We have 12 here. So 12 minus 8 simply means we have how many molecules left? 4 molecules of water. So if you want to write the complete equation, this is how you're going to write it. 4 MnO4 minus plus 3 N2H4 going to 4 MnO2 plus 3 N2, let's write it here, plus 16 minus 12 will give us 4 OH. 12 minus 8 will also give us 4 molecules of water. This is a balanced ionic equation. A balanced ionic equation. Look at it well. So, any question? All right. We'll continue next class. Ciao.